A very warm welcome. Good afternoon, ladies and gentlemen. Welcome to the group exhibit Hydrogen Fuel Cells Europe here at Hanover Fairground 2023. We are exhibiting here with more than 270 exhibitors. Everyone here driving the future regarding the hydrogen and fuel cell business. And I say business on purpose because we started here in 1995. With 7 or 8 exhibitors, and at that time no one had an idea what hydrogen is. They heard of hydrogen, but had no idea that we can use it as an energy carrier. So it's lovely to have so many exhibitors here, more than 20 countries, and we are here on 10,000 square meters. I'm happy to welcome you here in the technical forum. My name is Mona. I'll be the moderator for today. Please come and have a seat, have a complimentary drink. I invite you all. It's on my bill. Just come and fill the first row. That's my goal for the day, that the first row will be completely occupied. Enjoy our next technical presentation regarding power supplies for large-scale electrolyzers. 100 megawatt plus project lessons, and for that we'll have a speaker by VONK, the Business Development and Sales Manager, Mr. Bart de Vries. Welcome.
Thank you, Mona. Welcome everyone here. As Mona mentioned, it's been a long way up till today in this business. While only now, I think we're getting into grips of really scaling up the production of green hydrogen through electrolysis. And that's basically what we're going to focus on today. So we are very much in the forefront of the project developments and working on those large-scale projects. And today I want to share some lessons that we've learned over the course of the past period, and to reflect this with everyone else here. And have come some interesting announcement as well. So happy to see a lot of you here today, a lot of new faces, but also a lot of familiar faces from some of the leading companies in this industry with whom we work on these projects. So welcome all. So just a very short glance of what we're doing. I'm representing VONK, as Mona said, Bart de Vries as a business development and sales manager. VONK has a long heritage in all kinds of industries related to energy, more than 85 years. So we build a lot on our history and which we can leverage upon for solutions for the energy transition. We don't just do this in the field of green hydrogen. We also do this in uranium enrichment, in nuclear fusion research, with smart electricity grids, and we decarbonize oil and gas. We do a lot of activities. But if we look at electrolysis, because that's obviously the main topic of today, what we see is what we do is we make a connection between an electricity grid and an electrolyzer. And our main challenge is to be fitting with the characteristics of the electrolyzer and compliant to the grid. And obviously to do that at the lowest cost. Which means, because all electrolyzer manufacturers have different characteristics and quite often grid requirements and grid characteristics are not quite the same as well, there is no single solution to do this. Therefore, we see the converter as a bit of a black box for which we have multiple setups. And we obviously select the best setup for a particular project and electrolyzer setup to be, bottom line, most cost effective. And today, I've got a nice announcement that's going to be branded in a new name. Because we do a lot with VONK in the energy transition in general, we wanted to differentiate the activities for large-scale electrolysis in a different way. Because we see a lot of impact in this market, and we are absolutely one of the front runners, therefore we need to put this apart from the rest of what we do. So, as a short countdown, it's now available as NEA. NEA is new, but it's building upon the heritage that we have with VONK and 85 years of business in various demanding industries. as you can see, it's the link between a source of energy, whether it may be renewables directly or the grid, and the electrolyzer. As we are connected with so many of the leading companies and leading project developers in this industry, we learn a lot about how to apply our power supplies in this environment. And this definitely is a learning game. What we see now is that projects that we do at tens of megawatts of scale are completely different in application than projects at multiple hundreds of megawatts of scale. And quite different again to what we're going to do at gigawatts. So we want to share a thing or two on what we learn. What we, for instance, see is that for large-scale projects, the differences are still quite there when it comes to grid characteristics. It's not just AC voltage levels which have an impact, but it's also harmonics and power factor requirements. These become ever more stringent the bigger the projects become, because their impact on the grid becomes larger as well from an electrolyzer. And obviously, there's quite a difference in project environments as well. If you have a project that's, for instance, in a newly built situation, you have a completely different approach than when you're working on an existing site. The same goes when you're positioning your rectifiers indoors or outdoors. And therefore, it's not just a matter of choosing the right technology, but also to integrate this in the correct way to make it, bottom line, at the lowest cost. So what we do with our NEA rectifiers is offering the best fitting topologies at the lowest cost. I've got a number of them, as you can see here, available. One of the items that's really one of the main cost drivers in an overall power supply setup is your transformer. Could be even up to 25% of your total power supply cost. And there are a thing or two to learn there. And it has obviously a big impact on the overall setup, not just for your power supply, but also for the entire operation of your electrolyzer. So it's not something that you can decide that easily, but there is a big saving to do. And we are more than willing to share more insights in depth on this particular topic when we have a chat to talk a bit longer in person later. I mentioned something on where and how do you apply your project. So indoor and outdoor placement really makes a difference. If you're placing indoors, you can work with skids and so on. If you work outdoors, you have to work with your environment. If you are in an environment where there is a lot of corrosion, for instance, at a chemical site or near the coast, you have different kind of protection measures than when you're working inland with, for instance, a steel factory or something. And there's obviously quite a difference when you're working in an Arctic climate like Scandinavia, or when you're working in a desert climate in the Middle East. So all these things have to be taken into account when setting up your integration of your rectifiers. Therefore, adaptability is key to success for your rectifier. And we have set up our rectifiers in such a way that we can easily adapt them for either indoor use or outdoor use, or even with panelizing to make outdoor use very cheap. Another point of attention is cooling. So if you have an individual rectifier for a small project, it's not that much of a topic. You just apply a cooling unit just for this rectifier. But what you see in practice is that for a bigger project, you might want to connect it directly to a plant cooling system. Therefore, you can use a water-to-water heat exchanger, for instance, to make this connection. To have an independent cooling circuit for your rectifiers with specific requirements to cooling water, but still connect to the cooling system of a plant. However, if you're scaling a bit bigger, and you have, for instance, 10 or 20 of such rectifiers in place to meet your hundreds of megawatts of power levels, what you then could do, and it's quite interesting from a commercial point of view, is just set up a dedicated plant-level cooling circuit just for your rectifiers with their specific cooling temperatures and their specific cooling water characteristics. All these things should be considered when trying to achieve the lowest cost on a project level. So, I'm trying to wrap it up now for you as a couple of main takeaways. So if you want to achieve the lowest cost, a 100 megawatt plus level electrolysis projects for your power supply, the first thing that keeps being applicable is selecting the right topology for your rectifier. Which means selecting the right one is not leading to additional equipment, because that's expensive, that's what you want to avoid. So that's the first step. Then you look at how to optimize the transformer setup. There is a lot of cost in it. In most cases, it does not have a lot of added value. But if it is, you have to be aware of it. And we can provide you with good information there as well. And then you have to ensure integration in the project environment. Not just for packaging, but also for cooling. That's, I think, the core of what we want to share with you here today as lessons to how to achieve the lowest cost on projects at 100 megawatts and upwards. And obviously, we are very much looking forward to discuss this in a bit more detail for your personal interest and particular projects at a later stage somewhere here. And that will be possible at booth D40, just around the corner here where we are located. And very much looking forward to in-depth conversations on the topic later.
Thank you, Bart. Thank you for the insights. Thank you for introducing Nea. And thank you, audience, if you have a question. Then you can raise your hand at this time. I'll be scanning the audience if you have a question at this time. Well, I have a question, Bart. So you came to the exhibition before. This is not your first time. So for this year's fair, I would like to know, what topic are you most compassionate about? Meaning, if there's somebody approaching your booth, what are you hoping deep inside? What question will you be asked?
Well, I think the scaling in general, the impact of scaling is really something that, because we are so much involved in this, it's a continuous learning exercise, actually. So we learn from what we do, we learn from with whom we work, and this continuous learning exercise is for me personally the most thrilling part of this entire business development and ecosystem development even. So that's really a joyful part to be part of that.
And I like that you're saying that we always have to try things and learn and maybe exchange information with each other and just to work and collaborate. Yeah.
Absolutely. The collaboration is really what makes this fun.
Thank you so much for those words. Thank you.
You're welcome.
That was Bart de Vries from
Thanks.
VONK.